Hi. So, first of all, I would like to apologize for the last recording that did not go fine, but I'm sure this one should be fine, should be just fine. So, today we'll be rounding up our class. This will be our last lecture, and we'll start with indexes. So I'll quickly just share my screen. I don't want to waste any further time. I'll share my screen and okay. Okay. All right. Yeah, so before we go into indexing, let's just do a quick roundup of what we've done previously. Now we've talked about DML, we've talked about DDL, we've talked about TCL, and we understand how data manipulation language, data definition language, and transmission control languages work. So I would really strongly suggest and recommend that we, as soon as possible, start trying out our hands on all those queries that we've done. You don't need to cram them, just uh, understand the basic concepts and you'll be fine. Trust me, you'll be fine. So today we'll talk about indexes, SQL index statements. Just like the name, the word index, if you think about the word index, what comes to your mind? You probably would think of an index as a numbering or a way to organize something in a sequentially numbered manner, right? Now, let's see what the word index is by either Wikipedia or maybe any other dictionary online. So it says, in a book or set of books, an alphabetical list of names, subjects, etc., with reference to the pages on which they are mentioned. So in the previous video, I picked up one book, and that book should be far from me. Okay, it's here. So I opened the book. You can as well try this out. In case you are not familiar with what the word index in the book is, go to the index bit of a book. Go to the mostly usually towards the end of the book, mostly a published book, right? It could be a textbook, it could be a novel, it could be any of these self-help books. Go towards the end, you would see, most likely see an index section. In that section, you would see numbering, you'll see some words, and you'll see some page numbers. So basically what it's meant to achieve is, let's say let me get this book that I used in demonstrating some time ago. So I have this book here, the lean startup. So what this book has a section that towards the end that speaks about index. So you'll find out that there is a word and there is a page number. So those page numbers, when you go to those page numbers within the page, like a word here, for example, is audible metrics. And you can find audible metrics in page number 146 to 147. So if we open page number 146, we are likely going to see, we should be able to see that word audible metrics. So that's the basic concept. So an index is to help us, or to help the user of that book or that particular object that is indexed, to easily navigate around it, to easily find their way around it. The same concept here in SQL. So it says here that an SQL index is what? It says indexes are used to retrieve data from the database more quickly than otherwise. So if you if you are using an SQL index, it will help you if you create an index against a database table or a database, it would help you easily retrieve data. Now, let's say, for example, let me show us, let's see this database that was built before now. Trying to expand the database bit. I hope it doesn't take forever. Okay, thank you. So it's up now. So let's say, for example, we expand the customer DB, which we have been working with all along. This is customer DB, and I expand the table section. So in the last recording that had an audio issue, I'd created an index on a couple of databases. I'd created an index already. So, but I'll still recreate it so that we will see how you can create an index in SQL. Okay, so this is taking too long to expand. So let's just continue here. So it says, the create index statement is used to create indexes in tables. Don't forget, whatever you want to create, most things, in fact, virtually everything you want to create in a database, you use the create keyword. Now you are seeing create index. Previously, we saw create table, create DB database, create procedure or proc, which is for stored procedure. You can create view. You can use the create keyword. Now it says, note, updating a table with indexes takes more time than updating a table without, because the indexes also need an update. So only create indexes on columns that will be frequently searched against. You get that, right? So it's trying to tell us that we should keep in mind that updating a table with indexes take more time than updating a table without index, right? So as much as indexes have an advantage, they can as well have some little disadvantages. So here is updating a table. That's where the disadvantage could lie. But when you are fetching from a table, when you are retrieving data from a table, it can be as fast as you might imagine. So let's see if our table has expanded. Okay, our table has not expanded. This is serious. Okay, I think I might need to restart SQL Server Management Studio. This is getting out of hand while we keep explaining about indexes. Okay, that's opened. Can imagine, really opened, it's shut down. I think I need to restart it so that it's not anytime we want to open other tables, we'll be waiting for minutes. It's not going to help us. So now, to create an index, we use the create index syntax. This is a template of how you can create an index. Just say create index, then the index name, the name of the index. Of course, you are creating an index against a table, so you need to specify the name of the table, and that the name that you specify here for the table needs to exist. As much as it exists, you as well need to specify columns for the table where you are creating these indexes. So, and those columns as well need to exist. So let me reconnect to SQL Server. Now, we can as well create unique index. There's a create unique index syntax. What does it do? It creates a unique index on a table. Duplicate values are not allowed. So from the word unique, we find out that you cannot create more than one record or more than one index on a table that have the same. You cannot create more than one index on a table, right? That has the same value. So it must not have duplicate values, right? So this is the syntax to create a unique index on a database table. Create unique, just put the unique keyword in front of. So the difference between this template and this template is the create keyword. So if you take this create keyword and add it here in between create index, If you take this unique keyword, is a unique keyword. If you take this unique keyword and add it in between the create and the index keywords, it becomes a create unique index syntax. I hope I'm not fast. I'm not too fast. So now I expand databases so we can try out our hands on our index. I think it's faster this time. So I expand database, I expand customer DB, and I expand tables. All right. So now we have customer and customer two table. We have shoes and students table. Now, if I expand customer table, these are the columns. If I expand the columns, we should be able to see the columns that were specified all along, right? These are the columns. Now, if I go ahead to expand keys, I'm not sure we have any keys, so nothing comes up. Constraints, I'm not sure we have constraints. Triggers, we don't have any triggers. We've not gone to that level. But indexes, now observe that we have two indexes here, which is the index I created in the last video that had an audio issue. But since we have created an index or more than one index, we have created at least one index on the customer table. Let's see if the customer 2DB has an index created under it. So when I go to the index section, so there is an index on customer 2DB. So that doesn't deter us. So we're going to create more indexes on the customer table, right? So don't forget the query syntax. The syntax to create an index is create index syntax, right? You create index, then the name of the index, then you write the name of the table and specify the columns of the tables you want to specify, you want to create the index against. So basically, this is what it should be. So you see select, select is popping up in my mind again. So you say create index, right? Then you call the name of the index. So let's say we've written customer index in the customer ID index, customer ID index 2. Let's say customer ID index 3 for the purpose of this class. And after we created it, observe that that index would be added as part of the list of indexes under this customer table. Now create index customer. Okay, I think I have my caps on. Customer ID index 3, right? Now we now have to specify the table, the database table where we want this index to appear, or where we want to create this index on customer table. Can as well write dbo.customer on customer. Then we specify the columns in the brackets. So let's specify the column, just customer ID. I expected my IntelliSense to pop up for me. So let's try if this syntax is going to work. So understand something, observe something. This is exactly the same. This is similar to the template that we have here on this web application, on this W3 school. So if I copy this so as to juxtapose it together with what we have written, you find out that we have create index, then customer ID index 3, which is the name of the index that we're creating. Then this is index name, right? So we substitute customer ID index 3 for index name. On the customer table, we have a customer table here. Then columns, right? So this is exactly, we can as well go ahead to do something like this, comma, then write another column name, but we just want to use column customer name, customer ID for this for now. Excuse me. Okay, now if I execute this, let's execute and see what happens. I expect it to run properly. I expect to see commands completed successfully. Okay, that's the case. Thank you. So commands completed successfully. Now, if we come back to this index section and I refresh this bit. So observe something. We just have only two index is there. So if I refresh this, we should see customer ID index 3 appear just beneath customer ID index 2. Let's see if that's the case. So when I refresh this, now we can see that customer ID index 3 is now underneath the rest of the index. So it has been added to the list of indexes that we have on this table. So that is how easy it is to create an index. Now, let me show let me demonstrate how important it is to create an index. So let's say we expand the database table. It's coming up. Just a minute. So we expand the database table, and this is what we have. So let's say since we've created an index on this column, customer ID column, we don't expect to see it. Indexes are not visible, so to speak. So we don't expect to see it. So let's do something like script index as create to new query window. Let's see let's see what it's going to give us if we're scripting the index. Now we can see that it says it uses customer DB and it says go. Go is like proceed, right? Is a command to ask a SQL compiler, okay, move on, go on, execute the next command, right? So here it says create non-clustered index. This is the syntax of the index, and this is this is the column name where the index was created on. So you can script an index just like you can script a database table and any other thing scriptable. So an index serves as a way to, for example, there's something we call divide and conquer. This is more or less an algorithmic term. There's something we call now in divide and conquer, right? You divide a whole. You're searching. Let's say in search algorithms, right? You have a full set of records to go through, and you want to select one record. Now, if those records are 100 in number, the worst case scenario for you to select a record is for you to search 100 times. For example, you have 100 books stashed in a shelf, right? From book 1 to book 100, and you are looking for just one book. The odds, if you are searching serially from book 1, you check book 2, book 3 up until 100, the odds are there that if the book is the 100th book, you would have searched 100 times. And that same amount of time it took you to search for the first book would take you to search the 100th book. At the end of the day, you find out that your big O, or the time the time used to search for those books would be as big as the bookshelf that you are searching. So, but in this case, so this is this typical case where indexing comes. Imagine you have a database table that has a million records, for example, a million records, and you are searching for one particular record, and that record is the 1 millionth record on your table. Just imagine how slow it can be if your search query, or if your search is going sequentially. After searching the first record to second record, to search up onto the 100th record, to search up onto the 1000th record, to search up onto the 100,000th record. Imagine that sequential search. But by the time you index your database, right, this search and retrieval of information becomes much more easier, much more faster, much more time, much more, it makes life more easier, right? So as much as we can create an index, of course, tomorrow you don't want to have an index available anymore. Maybe there's some business rules, business requirements that makes you now not want to use the index, or maybe you find out that the index is not making your updates faster, and you just want to do away with it. You want to remove the index from that particular database column. You can use the drop index syntax, which says drop index name plus table name, right? So you can use the drop index syntax and it works very well. So in the same vein, you want to alter the database index that you have created. Maybe the index needs some modification. Maybe you want to you want to add more columns to the index, you want more columns to be indexed, but initially you had just 2 columns indexed or 1, for example. You can use the alter table syntax. Then you use okay, this is for MySQL. You can drop your SQL index. You can drop your index using MySQL in MySQL using this syntax, alter table name, and dropping it. As well as you can just drop your index, right? And there should be an alter statement for index. Okay, so that being it for index. So for auto increment, the next thing we're going to talk about today is auto increment. Excuse me. So we will talk about auto increment. So imagine you create, I think I'd spoken about auto increment in a previous video. So let's move straight down to views. Okay. Now, when you talk about views, when we talk about views, we mean it's sort of a table, but virtual. Now you've created your tables, right? You want to retrieve information from your table, but you want to retrieve it all in a single format, like a table-like format. So you don't have to go ahead to start creating tables and storing them, right? You can just use a view such that when those records are returned the way you want it, it's returned in a form of a table-like structure, right? Right. So it is not a table, it's like a virtual table. So here it says in SQL, a view is a virtual table based on the result set of an SQL statement. So this view is based on the result set of the SQL statement that you would have written or you had written. Excuse me. So it goes ahead to say you can add SQL statements and functions to a view and present the data as if the data were coming from one single table. So exactly what I had stated just shortly ago. So now let's say you want to retrieve data from more than one table and you want that data to be presented in as though you are reading it from one table. So let's say you are reading from 10 tables and you want them to look like to be presented in a table, so to speak. So in this context, you use a view to represent a virtual table. You can add SQL statements and functions to a view and present the data as if the data were coming from a single table. A view is created with the create view statement. Remember, we are still coming across the create syntax, the create keyword here again. So you remember in DDL or DML, there's a create syntax, right? So we're meeting create again. So here we're creating a view. We're not creating a table in this time. We're not creating a stored procedure. We're not creating a database. We're creating a view. So the syntax to create a view is what? So you want to create a view, you just use the create view syntax. So what we will do is we're going to copy this. It says create view, then you specify the view name as, then you now select, you can now do your query from table where a condition meets. So we created a view in our last class, though I'm not sure if that view session, if the view section of the video was clear enough. So, but I'll expand this. Let's see if we have a view here. Okay, so we have customer shoes view. So once you create a view, under this views bit, under this view section, you can find the view you've created. So we are going to, for the sake of this class, we're going to create another view and let's have it appear here. So I'll remove this query and I'll save the template that we've just copied. So just as we usually do, we write our create view statements. Then let's call it, we have customer shoes view 1. Let's call it customer shoes view 2, right? Now, we've created the view. This will create our view. Then, but we need to tell our view what to have, like where to get data. So we'll do the select. We can do, let me do from, so that I can have IntelliSense suggest for me appropriately. So I can do select. Okay, let's do from customer table. Customer table, right? Okay, customer table. So I'll select. Let's say we select. Okay, I think there is more to views. So it says a view only shows up-to-date data. Okay, let's proceed. I was thinking something. So we can do select customer ID, column, customer ID, select customer ID. Okay, then we can do, what other column is there? First name, can do first name, and we can do last name. Then our from statement kicks in, from customer table, right? Let's say where what exists. Let's say, okay, let me open the customer table and see what we have. Okay, let's say where customer ID is equal to 11, where customer ID is down here is equal to 11. Okay, so we do away with this template. We have our select statement, right? Why is this quickly coming up? So let's try and run this. Incorrect syntax near select. Okay, let's see, select. Okay, should I have put, oh, my bad. I should have put as here, as, so that that particular error squiggly lines will leave. So when I execute this, it says commands completed successfully. Then when we come back down to this section and we refer to the view section and we refresh, now we can see that we have customer shoes view 2 here. So we've created our view, right? We've created our view. Let's find a way to execute this view. So this is an example of a view. So let's start from example. So let's find a way to execute our view. So executing a view, executes a view in SQL. pops up for us. So first run SQL. Okay, that's in depth. Okay, creating and executing a view. So let's do this. So here it says this is to create a view. Select this, then execute a view. Select start from view. All right. So let's execute our view using this template. Select start from, then this view name. Right. If we do this, I like using all caps for anything that would be bluish for me in SQL. So if we execute this, now we see our view executed as though it's a table on its own, right? So this is basically an example of how to create a view and how to execute a view. So it as well goes further to tell us here that we can as well update a view. If you can create something, you should be able to update it, right? Like modify it, right? Like putting as for the case of databases, add more recent data and remove redundant data or remove data that needs to be removed. So we can as well update a view. A view can be updated with the create or replace view statement. So we use the create or replace view statement to update a view. So this is basically the syntax or the table or the template for updating a view. For example, we can say create or replace view name as, then you write your select your query statement. You can drop a view. As much as you can build, you can destroy, right? You can build, you can create, you can drop. So dropping a view is as simple as using the drop view syntax. Just say drop view, then the view name. The view disappears. But make sure you're dropping a view that you don't need anymore. If you drop a view that you might end up needing sometime in future, you might end up recreating it. You might end up needing to recreate it. So that's for SQL views. So we've spoken about data types. We're not going to go into injection. Injection is way beyond the scope of this class. Hosting, same thing. So we've spoken about data types. And so this is basically going to be, okay, so maybe we'll just do a roundup, right? Is there any other thing I might want to touch here? Create DB. Oh, we don't create DB, backup DB, everything here, DB, we've done them. Constraints. Okay, let's touch on constraints. But I really urge us to just take this list and go through them, practice them, and you're fine. Completely fine, like really fine. You have your SQL Server Management Studio up. You have this web application, this W3 School for SQL bit up, and you practice. That's all. But if you listen to these videos, you would understand everything that you need, the basic concepts, basically, you would understand it. And trust me, you don't need to cram anything. Just like I keep saying, understand the concepts. Then you can always research. You can always Google it. Googling. You can never underrate it though. And it's not when you see somebody Googling something, people think if you Google something, you don't know it. Of course, you might not know it, but you are smarter if you Google it because it's there for you. Why would somebody start going why would somebody, if you have a faster way of doing something, why not just take the faster way instead of killing yourself over something that you would have done easily or easier. SQL create constraints. So now, if you put data in a table, you will need to, sometimes we might need to create rules for this data, right? Or even rules for this table, right? So constraints can be specified when the table is created with the create table statement, or after the table is created with the alter table statement. So a constraint, for example, here, this syntax for creating a constraint, we can see that in this syntax, we can see that here it says create table name, right? Column 1, data type, then constraint. Then this constraint here comes when you want to put a check against a kind of a database column. So an example of a constraint that can be put is size of the size of the column, or the type of okay, let's go down and see the kinds of constraints. SQL constraints are used to specify rules for the data in a table. So when you put a constraint in it for a table, when you specify constraints, you are directly telling SQL that these are rules that you should follow before adding data to this table, or these are the rules that the data should abide by before it can be accepted into the table. Now, it says constraints are used to limit the type of data that go into a table. This ensures the accuracy and reliability of the data in the table. Now, the data needs to constraints helps you as well to ensure that the data in the table is accurate and reliable. If there is any violation between the constraint and the data action, the action is aborted. Of course, let's say you want to put in you want to put in first name, right? And first name, you want to put in somebody's first name, and instead of you to write a string into the person's first name, you are putting, let's say, a number or something else. Of course, that particular action will not complete. Constraints can be column level or table level, right? You can specify constraint for just a column or one or more columns, or you can decide to specify constraint for everything in the table, for the whole table, like table-wide constraint, right? Column level constraint apply to a column, and table level constraint apply to the whole table. The following constraints are commonly used in SQL. So most of these constraints, we have looked into them. Number one is the null, not null. What not null basically does is ensures that a column cannot have a null value. A column not having a null value means you cannot put null in the table column, right? Or basically the table value cannot be empty, in other words. So unique ensures that values in a column are different. So no two column values are the same, right? So now what SQL will be doing is, the moment you put the first record, of course, every column there should be every to check that, okay, this last column that I've put a value into, does it match with any other values of the previous values that has been put into a column, to check. So to make sure that all values that go into a column are different, no one is unique. Primary key is another type of constraint that we usually apply to a database or a database column, database table. Primary key is a combination of a not null and unique. So when a column does not accept a null value and a column is unique, the combination of these two constraints makes the column a primary key. Unique identifies each row in a column. So that's what a primary key is all about. Foreign key prevents actions that would destroy links between tables. Now, a table, most of the times, would have a relationship with another table. That's why it's called a relational database management system, or relational databases. Now, if you do not specify a particular column as a foreign key to another table, right, it means there is no relationship between that column and between that table on that column to another table on any other column. So foreign key prevents action that will destroy links between tables. So using a foreign key helps you to properly link a table column to another table column or to another table, as the case may be. So foreign key and primary key are very, very important in relational database management. So I would really encourage us to take our time to understudy foreign key and primary key. Check ensures that the values in a column satisfies a specific condition. Check. So it's just like saying, before something happens, before you insert a record in a particular column, right? Make sure, go and make a verification. So it ensures that the values in the column satisfies a particular condition. So go and verify that these conditions are met before you proceed with the insert successfully, or before you proceed with what you want to do against that table column, right? So default sets a default value for a column if no value is specified. Now, sometimes some people, what they usually do, some database developers and admins, if they are creating a record and they don't have, and if they want to specify a table value, right? And they know they cannot. So basically it's used to set a default value, right? So when you set a default value for a column, a database column, it means that if no record if that column is not supposed to, is not having any value, use that default value to put in place of a null or in place of an empty column value. Now, create index, just like we just saw, is used to create and retrieve data from the database very quickly. You create and you receive data from the database very quickly. So that's what constraints are all about. So you can deep dive more into each and every one of them. So if you click on not null, I'll right click and I'll open a new tab. If you click on not null, you'll be able to see much more things about not null. So not null is here, unique is here, primary key here, foreign key here, check default. So these are everything there, and they are all here. So that is for constraints. So that is for constraints. So let's see if we can look into SQL exercises. Lovely. Now, you can test your SQL skills with W3 Sql exercises, right? So these are some exercises that I will encourage us to do. So here it says start SQL exercise. So if I click on this, now you can see, you can just quickly write your SQL statements. So if I say select star from customers and I click on submit answer. So this is supposed to be select. I click on submit answer. It says correct. Next. If I do this, maybe it expects me to write select, then star, then from customer. So this if I submit answer, it says not correct. Oh, okay, try again. Select star from customers. So basically these are very basic statements, but I know by the time you keep going through all of them, you can see SQL joins here. We can click on exercise 1, for example, and you can see select star from others left, join customers equal to this on this, right? So you can just try out these things. Try it out. I would love to get a feedback from you guys that you have tried it. So try it out. Make sure you just give it a trial. It shouldn't take up to 2 hours to complete everything here if you are doing it on a stretch. Except you want to do it as the spirit leads. Maybe today you do select, tomorrow you do SQL where, next tomorrow you do. So, but it would be good if you can just take out a chunk of time and do it. But the most important thing I still keep saying is make sure to grasp the concepts, because once the concept is known, no worry, it's known, right? If you see something that is similar to SQL, maybe new technology comes out tomorrow, you can easily jump on it and flow with the tide, understand it and start using it to build or work or do whatever you want to do with it. Yeah, so uh this is likely going to be where we are going to end the class. I would have had an interactive session with us if this wasn't a solo recorded video. I'd have really loved to ask us how the class has been, our recommendations. So it would be good if I'll still ask. So it would be nice if you can, send me your feedback. You can decide to do it anonymously so that in case you don't want me to, don't want it to be as if Chidi will say I'm giving him a bad or a not so good review. Trust me, the worse the review is, the let me say, the worse the review gets, the better it helps me, truly. So I'll be looking forward to your feedback, guys. And trust me, I will not take any offense for any feedback that sounds not so good. I wouldn't want to use the word bad. I would rather say not so good, but it would rather help me to, look for ways to augment the way I teach. So these feedbacks would help, to help me to help you as well. So maybe what I could have done is before the classes, but I couldn't have asked for feedback before the classes because you wouldn't have known my teaching method and you might not have understood any concepts as at the time. So I think this is the best time to ask for feedback. So I'll be really glad if you guys can go out of your way to give me really sincere feedback, constructive ones. Yes, even if you want to tell me I'm crazy, there are constructive ways to say it, and I will get the idea, I'll get the picture from it. So please you can drop me your feedback personally. You can drop it in your WhatsApp group. You can tell somebody to tell me. However, then as much as I want the feedback, I would really want to commend the class. This has been the most interactive class I've had since the start of this this cohort sessions that we've been having, and I hope it keeps getting better. So I want to commend each and every one of you. You guys sound like people that you sound so enthusiastic to understand these concepts, and I know that you will you will exceed your own expectations so long as you keep doing what you're doing, right? um they used to say this network marketers, they used to say that or let me say people like Malcolm Gladwell said it takes about 5,000 hours of doing a particular thing to get mastery of it, right? And people say it takes so many, things like that. So you don't win by quitting. So you win by staying true to the hustle, staying true to the learning, staying true to what you know how to do. Even if truly you see girls that are seemingly genius in these things, in software, in data mining, in data analysis and stuff. You see them, they were not born with those knowledge, they learned it and they stayed true to it until they got to a particular stage in their career that people can now look up to them and want to involve them in their dealings, right? So if they had quit, they wouldn't have been that reverenced or that's great or something. So I'm using this opportunity today to talk to us, tell us that please just continue. I'm sure I trust Kuku to really put you guys through everything you need to know. Another thing I would like to as well recommend is when it's time to develop those CVs that you would probably use to get the dream job, right? In data analysis or data analytics. Look for a model CV. Try to find a CV that of it someone who has achieved quite a lot in their career. model your CV after that, right? Then do a reverse engineering, work from the back, like work from the end product to the front. So basically, when you've done all those things, when you've mirrored your CV to look like that of your role model, for example, you can now start learning those technologies that you've put on your CV, right? It's a faster way to go, right? So because you know that if you go for an interview, those things on your CV, you would need to defend them. Then you put yourself on the pressure to work with those technologies, understand them very well, such that, and even build or, carry out some kind of projects, right? Such that if they ask you any question on the job questions, you can, with the experience you've gathered while building those projects or while working on those projects, you'd have something to tell them, right? So there are so many ways we usually get around these things. So but it's not to keep you any longer. I would really like to say thank you for everything. Congratulations for finishing this class, and I will be expecting good news. I'll be expecting to hear good news from you guys. All right, that ends our SQL class for today for this cohort. And once again, I wish you all success. Bye bye.